Okay, let's get maybe started so that we get on with our days. Welcome everybody to this next episode of our HDF Clinic. Before I have a little bit of material prepared, but this is first and foremost about people who have issues, questions, concerns about HDF5, and now is the time, or at any time during this event, to raise a question, raise an issue. Are there any questions?
Yes, I have a question. Maybe you
Sure.
saw on GitHub there was a discussion linking with zlib, and I think I don't know if we are misleading user, and what we are doing in our build systems, because I'm really convinced that building a library and a SO library shouldn't require to link with anything, with any extra libraries. It's only when you build executables. And on the build lines, at least as I recall, when using auto tools, math libraries, zlib library were always during the build process of libhdf5. So am I hallucinating, or we kind of have a problem? Maybe it's inherited problem from the build systems, but user is really confused how he can, without much hacking, how he can build his application with static libraries. So this may be good thing to review build process and see what we are doing and give recommendations to the users, because I believe he experienced multiple problems there, but it should be easy problem to resolve. It shouldn't take days to resolve.
Yeah. Well, I would admit that I'm out of my depth here. I mean, the last time I did something like that, that's a long time ago. But
No, we're trying to help, but it's it's not he is asking for, so I don't know. I believe solution he's looking for.
Yeah. I mean, we don't want to mislead people also, and either. Okay, I wish someone from the engineering team were here. But yeah, I'll bring it up with, and I'm sure the issue is being looked at, but then sometimes.
Right. It was looked for, but I don't think user has an answer.
Okay. Any other questions, comments on this or any other topic related to HDF? No? Okay, good. Then I'll jump in, and then again, if a question occurs to you at any point, feel free to raise your hand, interrupt me, make yourself heard. Okay, this is something that I enjoy doing, and I've looked at for quite some time, and there are some new developments, and I want to give you an update. And the where I'm coming from is, I think, for a file format such as the HDF5 file format of sufficient complexity, let's put it that way, having this file format, the file format specification or description in some kind of machine readable or machine processable form, I think is a good thing to have. And so I'll post this link. This is the HDF Clinic GitHub repo. It's just in a branch, but I'll move it over to the master branch. So all my notes are here in case you want to come back to this later. So I'm trying to explain here, what do I mean? You might say, well, what do you mean specifically by a machine-readable file format specification? Well, it's definitely formal in some sense, but definitely it can be parsed and analyzed and potentially used directly for code generation or for reading or writing of the items so specified. And the contrast, contrast this with, I'm not trying to suggest that our current file format specification is sort of in a desperate state or is in a poor shape. It's not. My best example for that would be how many incomplete, but also how many complete independent implementations of direct readers and writers for HDF are there. That speaks to that a specification that's written in a human readable language, that doesn't mean it's necessarily bad or ambiguous or counterproductive or whatever else. So no, I'm not trying to suggest here that our current specification is sort of in dire straits. It's not. But then, yeah, key features would be for a machine-readable version, perhaps that it's written in some kind of markdown, whether it's JSON or XML or YAML, or could be a domain-specific language. It really, since it's supposed to be understandable by machines, it should be pretty much unambiguous, and yeah, down to the necessary precision level, especially for file format specification. And yeah, it should be tool-friendly in the sense that we all know how expensive it is to maintain software, and the best software in a way is the software that maintains itself, in the sense that, yeah, you can always go back to, for example, such a specification, whether it's a specification for the file format or something else, a workflow, a behavior, you can generate that code automatically. That's again code that you can just, you have some kind of, whether you use meta programming of some sort or other code generators, that's a win. Automation is always a win. And now you might ask, okay, I get the what, why is this a good idea? But then again, I think the evidence is sort of overwhelming. First of all, if your specification is reasonably non-trivial, as is the case with HDF5, it's a matter of trust. And over the history of HDF5, that's an argument I think that's been made many times in different communities, that people insisted on saying, okay, I got this floating point number here, show me exactly the spot in the file where that is represented in some form in bytes. And that is a legitimate question. But then people have sort of different expectations about how involved the process of establishing, let's say, that location is. But certainly to build trust is also a question of that people want to be confident, especially when we talk about portability between runtimes and architectures and platforms and so forth. You want to make sure that if you say, okay, I take the file format specification and I'm starting over, like pure HDF, for example, in C#, no dependence on the C library, you want to be sure that the way how the C library creates HDF5 files is first and foremost fully compliant with the specification, but also there are no secret handshakes, or you might say, the maintainers, we sort of play footsie in some sense with the specification. You don't want that, and the best remedy or the best countermeasure is have independent implementations or independently verifiable specifications of some sort. Then I mentioned already portability, maintainability. Again, that's the ideal scenario where a change in the specification sort of propagates through to your tooling and so forth. So there are definitely efficiency savings. Validation and debugging, it should be a specification like that, if it's useful, should help you with validating and verifying whether an implementation conforms to the specification, and potentially, if there are corruption issues or something like that, help you to a degree recover from that, or at least understand exactly what's going on. And then, yeah, I'm not going to talk about reverse engineering or exploits and vulnerabilities, but that's another interesting area. Okay, why? I think we can agree that these are all good reasons why such a machine-readable file format specification might be a good thing. Now, you then might ask, okay, I buy the what, I buy the why. How difficult is it to pull something off like that? And just for fun, there is an interesting report, I think, to the Canadian government that is actually about healthcare. But the authors there draw an interesting distinction. They sort of distinguish simple, complicated, and complex problems, just to sort of bring it to ground level, to human, relatable complexity understanding. And in this paper, they have an interesting table that I reproduced here that says basically, well, a simple problem should be something for which you have a recipe, for example. So you have a recipe, you can then look at it from how much knowledge do I need to really apply that recipe? Do I need a specific expertise? How consistent are the results, reproducible? And is this fundamentally that I can approach in an optimistic way? So that would be a simple problem. There is a recipe. There are other simple problems, but just to have something specific in mind here, follow a recipe. The next level up would be a complicated problem. A complicated problem is like, yeah, sending a rocket to the moon. Now, you're not going to do that sort of just starting from first principles. There will be failed attempts initially and so forth, but eventually you'll get it right. And with every rocket, with every launch, you will get better, and you will become more confident. And rockets behave in similar ways, although there might be some rockets that go to the moon and other rockets that do something else, that just bring satellites into orbit. Okay, so that's a complicated problem. And then what is a complex problem? Well, a complex problem is really, it's very different from these other two. If you thought sending a rocket to the moon was complicated or was complex, not so much. But what is really complex is actually something that is very human, raising a child. And sort of, yeah, previous experience may or may not help. Whether you have specific expertise, you are a medical professional or a great teacher or something like that, your outcomes may vary. And so expertise is neither a necessary nor a sufficient condition here. There will always be uncertainty of outcome, even if you start with identical twins or otherwise along physiological or otherwise lines, identical initial conditions, so to speak. So that's a complex problem. Now, coming back to machine-readable format for a file format specification for HDF5, I would put it sort of in this area between simple and complicated, in the sense that, yeah, you can probably break it down into a sequence or a set of simple steps. It's still overall not a simple problem. I wouldn't go that far, but it can be broken down into simple steps. And now then the question is, okay, how do you pull this off? And when I started about thinking about this problem on and off, I started, for example, this is a classical text, this book by Peter Seibel, Practical Common Lisp. If you read chapters 24 and 25, he very skillfully uses the meta programming capabilities in Common Lisp to basically write a MP3 file parser, MP3 as one of the binary file formats. MP3 is nowhere near as complicated as HDF5, but still it's not completely trivial. And so in this book, in chapters 24 and 25, Peter Seibel pretty much shows you how you can handle that using Common Lisp. There are other specification languages. For example, there is a YAML-based specification language and sort of tooling around it called, I'm not sure how to pronounce this, Kaitai. I personally, I forgot how many years ago, I discovered this tool called GNU Poke, which I like very much. But then I would also say, if you just want to see close up without a lot of use cases and metadata cache and all the other mechanics around, if you just want to see how do HDF5 files get written and so forth, and how do all these primitives get assembled and so forth, I would recommend look at the pure HDF, that's the C# based independent implementation of the file format specification. Look at that. So up to this point, there's actually nothing new here. I talked about this a few years ago, and but then there is still, even if you say, okay, pick your poison and then just do it, there's a lot of there are a lot of details to sweat. Now, what's new? Well, what's new is you could say, okay, with these large language models now, I forgot if in the last episode that I did or the episode before, I showed an example that nowadays ChatGPT, for example, can take the H5 dump output. So you can take output from H5 dump and present that to ChatGPT and say, can you write me a C program so when I compile and run it, that it produces an HDF5 file whose H5 dump output then looks like what I'm giving you here. And it actually can do that. And that was a pretty impressive feat. And so let's take that to the next level. Why not ask ChatGPT to do this? And I just did it. And so what I did is basically, these are all linked here. I took the, nowadays with ChatGPT supports what's called tools, but it also supports this RAG, this retrieval augmented generative AI. So you can hand it specifications, so you can hand it a copy of the HDF5 file specification, although that's been around for a while, so there is a chance that it was part of the training set, although no guarantee. And likewise, you can take the GNU Poke manual in PDF form and hand that to ChatGPT. And in this case, I used the GPT-4o model, and that's sort of the current model. This is sort of the general purpose model. There are some, I'll come back to that later. There are some models that are sort of more optimized for coding and logic tasks and so forth that might do a better job, but I have not explored that. So I use just the vanilla GPT-4o. And okay, so now you might say, let's do a live demo. Well, there are a few catches here. If you do this, and I encourage you to do this and compare your results with my results, there are all kinds of problems with doing a live demo, so to speak. So I can prepare, and actually prepared for this. Obviously, I prepared the notes. The probabilistic nature is a problem. It's also critical how you set up the context. Sometimes I noticed your mileage, you might have a similar experience. When I tried this very early, I'm an early morning person. Early in the morning, ChatGPT is very fast, very responsive, and so forth. When I come here to the office at 10, 11 o'clock, it just sometimes slows down. There are timeouts, so I don't know what the performance would be right now. So I'd rather not do that. and then of course there are demo effects and so forth. And so I'm not going to do that. But then what I will do is this thread will continue, not necessarily next time, but I'll be back with this in a few months. You can do several things. Number one is you really want to be very scripted and very deliberate about how you prime your session, if you wish. So have a prescribed intro prompt, pre-fill your prompts. I mean, sometimes we just type things and the formulation is slightly different, leading to different outcomes potentially. Then temperature, if you can control that in your model. But then also what I have not explored is actually in ChatGPT, but also in many of the other tools, you can build your own agents, or I forgot what the nomenclature is. ChatGPT calls them custom GPTs. So I have not built a custom GPT that is sort of preloaded with the specifications and maybe some additional materials. So with all these caveats, I have a link in here. So I did a session and I shared that link publicly. So if you click on this link, I'm going to click on this link right now, or I might have it open already. Just for reference, I had the poke manual and the file format specification open. But let me open this. And actually, I think I have it open here. And is the font big enough, or should I make the font a little bigger? Is that good? Yes? No?
Yes, it's good.
Okay, good. So this is a session that I don't see a date here, but it doesn't matter. It was maybe 2 weeks ago or something like that. So I started by uploading the two specifications, the file format specification and the poke manual. And then a big mistake, I jumped right in. Again, there should be a script and I sort of should set the stage a little better, but nevertheless, I jumped right in here. And I said, okay, call them modules that you would create in poke for a specific binary format, whether it could also be TCP packets or something like that, or the ELF format, the binary format. You call them pickles, these modules. So this is jargon, this is poke jargon. So I'm just telling ChatGPT, I would like to create such a pickle for the HDF5 binary file format. And can you help me with that? And for example, let's start with the HDF5 file superblock. And how would you represent that in poke? And then cheerful, a very cheerful response. ChatGPT sort of tries to break down that task a little bit. So it sort of echoes back. I don't know why it probably tries to detect the syntax here, thinks this is VB.NET, which is pretty silly, but that's okay. So it sort of regurgitates and says, okay, this is what I'm seeing here with the format. Then it comes up with that sample poke struct, and we don't have time here today to look into this, but if you're familiar with the file format specification or ever looked at the C code, this will look familiar. You have the signature, then you have the version, and then depending on version, later things change a little for versions 0 and 1 and 2 and 3. But you find out about the size of offsets, size of lengths, and then there are file flags. And then, yeah, in versions 2 and 3, you have sort of a base address, extension address, and a file address, and then where the header of the root group is located, and you have a checksum. And it also recognizes, for example, that, yeah, the size of offsets and size of lengths, that actually tells me this offset here in what units this is specified and so forth. So that's all good, but that's just commentary. And here's actually some actual poke code. So in a poke pickle, you basically define these types. There are structs or unions or maps. There are different data structures that you can do. And then, of course, you can sprinkle in things such as verifying the file format signature, for example. And the way you would do that is, yeah, you would define the signature, for example, as just a byte array, and then define a function that basically verifies, given a byte vector, if the two are matching. Now, this all looks very interesting, and we don't have time to dwell too deeply here. But what you see here already is, and I have that in the comments later, the syntax is just riddled with errors. So if you, this kind of looks like poke, and this particular example probably would compile just fine. However, this simple one wouldn't work because, for example, there is no const qualifier in poke. So again, ChatGPT yeah, thinks that that is a good thing, or that is information worthwhile pointing out. But in poke itself, there is no concept of a const variable in this case. So this would work if you replace the const by just var, var, for variable, but there is no such thing as a const in poke. But side note, but there are many little syntactic errors that the poke compiler will point out to you, and if you are a little bit versed in the language, you will catch up with them. But sort of your initial, don't be disappointed, and at this point sort of throw in the towel and say, oh, this is not going to work. And so it's by and large correct. Sort of the outline, the structure is correct. However, in detail, there are things that need to be corrected. Okay, so this covered versions 2 and 3 of the super block. So then on its own, it's asking me, well, what am I interested in version 0 and 1? Yes, absolutely. So again, the game plan is very similar. And of course, in version 0 and 1 of the super block, there is a lot more information there compared to versions 2 and 3. And this is all cool, similar playbook. And then you can define a union, because then you want to have, like, when you read a super block, you just want to say, here's an HDF5 file, read this super block for me and potentially pretty print it. But I don't want to get involved into, you figure out as you read it, you will know what the version is and then just generate the right thing. So this is where you would use a union, and then these the content of the union can be conditional on the superblock version encountered actually, and so forth. And then, yeah, we don't have time to talk about maps. Then it tries to be helpful. So one, poke is multiple things. It's a language, it's a tool, it's a compiler, it's many of these things. But if you are working on the poke with the poke tool, the poke prompt, you would load this PK file. This would be one of these pickle files. You would load that, and then you would actually, you would, before you do that, when you invoke the poke tool, you would say poke and then the name of the HDF5 file, and that would be then part of the context, because when you invoke this function here, the question would be, well, how does it know about the HDF5 file? I didn't tell you. You specify that when you invoke poke, and that's how this gets all funneled in here. Okay, so I'm gonna go through this very quickly. So then you can sort of tackle symbol tables. You can parse data type messages. It will do the recursion depending on the data type class and so forth. You can look at attributes, the different B trees and so forth. So again, modulo, tons of syntax errors. I was very impressed by how it sort of pulled all these things together. And maybe I will, again, you have the link in the notes, so if you are interested, you can you can look at this and do your own experiments and so forth. So that was very encouraging. Now the question is, okay, where do we go from here? So first, I made already a few observations. Number one, yeah, there are at the moment tons of syntax errors that might be not exactly fixed, but maybe reduced a little bit by either using one of these custom GPT models, or I have not used yet one of these more where it says, oh, this is particularly good with logic and coding tasks and so forth. So O3 Mini High, for example, is one of the models that might yield better results. I also have not tried this Kaitai tool, which is YAML based and might be a little easier than Poke. Poke, I mean, they're both DSLs. It's just Poke has its own syntax, whereas Kaitai uses YAML. So maybe ChatGPT or Copilot would have an easier time with that. Now, what would be the next steps? Well, assuming I can work with others to put together a first version of this pickle and then improve it over time, refine it over time. I might actually, I was thinking about maybe getting in touch with Jose, the guy, the brains behind the Poke project, if he would be interested or can recommend someone in the Poke community that could add sort of as our, that act as our Poke main advisor, that would be great. But then use cases, of course, ultimately the goal is how do we tool this? How do we create value for our users in terms of the tools that we might give them that they might find useful in their day-to-day lives? Well, off the top of my head, I see sort of at least two types of or classes of tools. One would be read-only tools, so we don't really do anything to the HDF5 file. But then Poke, these structs that we defined and so forth, you can write. You can write to the same file, you can modify the existing binary file, but you can also write to a new file or to an in-memory file. Poke has these so-called I/O spaces that cover a range of sort of storage types, if you wish. And so on the read-only side, well, definitely creating a better H5 debug, call it H5 Poke, would be a great start. You could develop something like a file consistency checker, something that just walks over your HDF5 file and looks around if things are sane and or if there are sort of gaps or oddities somewhere. Definitely something, H5stat is a great tool, but I think it could be refined with respect to certain low-level information and perhaps combine that with some kind of visualization. Also, data extraction, if you just want to extract the raw binary data from a specific chunk or something like that, or the value of a specific attribute or something like that. Oh yeah, that's a good one. Elena suggested a tool to find the minimum version needed to access all the objects. Yeah, great idea. And then on the read-write side, simple repair jobs. Some of you who have used Swimmer or something like that, we have the simple H5 clear tool. Yeah, that would be a trivial thing in Poke. Other super block fixes related to driver information or extensions. Once we've mastered sort of simple repair jobs, we can look toward more complicated repair jobs, for example. But then also we could do local data transformation. I mean, H5 repack definitely has its place. And of course, with all of this, we don't have hands-on experience yet, but that's why it might also be useful to talk to the Poke community about performance. So it definitely Poke is intended to create binary utilities to be like HDF5. The HDF5 file format, the HDF5 library and file format are sort of universal in the sense that when you create your domain-specific data representation, you are creating your own format, so to speak. And likewise here with Poke, it's really intended you create your own binary tools for your specific domain. And in this case, the domain, so to speak, would be HDF5. But then how performant this is in practice, I don't know. I have no experience, but it would be interesting to have a conversation with them about it. And then, yeah, sky's the limit. So more ideas, email me, we can have a forum post and so forth. And yeah, that's where I'm going to stop, and we are out of time as well. Any questions?
Yeah, a couple of comments.
Go ahead.
Slash questions, I could view them that way. So the end result that you're actually aiming for here is the Poke specification as the machine-readable version of the format. The use of the AI tools was just a mechanism for getting there.
Yes, at least at the moment. At the moment, I'm thinking this process of creating the Poke pickle, as the jargon goes, is a pretty low. I mean, you know from experience how intricate the process is of getting all the bits and bytes right, in a practical implementation. And I think a tool like ChatGPT could accelerate that process. It's not going to be perfect. It's not going to do 100%, but if it did 80%, and then have an expert sort of do spend the 20% massaging it and getting it ready, I think that would be a big win. But then, of course, coming back to your comment, yes, once we have that pickle, to then sort of take it to the next level and think about, for example, optimizing layouts in the file. What can LLMs or other, not necessarily LLM tools, other tools contribute to optimizing layouts, if not eventually sort of evolving the file format, saying, yeah, we sort of keep the tool just keeps seeing something and says there is a better way of doing this. So yeah, thinking about
yeah, sure, the same way you would say, write me some regression tests, or where is the bug in this, and all those kind of LLM-ish questions to ask. Right, so that makes sense. So the Poke spec, the pickle, is a reasonable place. AI tools, I don't know yet. It might be a net win, might not. Because there's plenty of places where if it hallucinates slightly in a place you don't catch, then you're going to have bugs that are very difficult to track down. So I've experienced this in the AI coding tools already, and putting them out in a realm where they're pretty experimental here, what you're doing is bound to have steep cliffs that you navigate past. Okay, well, it would be interesting to see the follow-up on that whole part was, I would be interested to see what the AI tool can make sense of some of the world knowledge that's in the format spec. Like, this is a B tree. It's got to know to be able to reach over and understand B trees. And then what are the meanings around that?
Yeah. We don't have time, but you can see, I mean, if you look at that script, I mean, I poked in double quotes into the filter pipeline, into the B trees, and yeah, it definitely has, I recognize the themes, and it's definitely headed in the right direction. I also experimented, for example, here with pretty printing and so forth. That works pretty well. and yeah, printing object headers, and then recursively parsing data types. And yeah, but the proof is really to, okay, that's all great. Now let's go back to square one and start building that pickle and test it, and so that we can get off the ground and yeah, tackle more interesting problems. But I think it's a great help. It's at the moment I see this maybe as a productivity boost to just get this started.
Probably.
Yeah.
Cool.
Okay. Thanks. And then yeah, there were some good comments also here. Dan said, for example, yeah, machine-readable spec, attractive feature for long-term data storage. Yeah. And oh, Claude 3, I have not tried Claude 3. Yeah, there's only, I could spend only, I mean, in my spare time, I can spend an infinite amount of time because I find that very interesting and intriguing. But yeah, Claude is definitely on the list. And also, I have not tried Copilot. Yeah. Okay. Any other questions, comments? No? Okay, then, well, thank you all for coming. And yeah, well, I forgot. Please remember Hug. If you haven't registered yet or haven't submitted a paper or an abstract yet, please do. It's going to be great. It's going to be hybrid, so even you may not be able to travel to Europe, to Hamburg, but it's worth tuning in and participating at the time of day that's manageable for you. And yeah, so thanks for coming, and we'll be back next week. Thank you.
Thanks. Bye-bye.
Bye.